Hello, we're going to talk about chapter 25 and solve some problems just to make sure that we really understand this chapter. This chapter talks about current, resistance, and electromotive force. This is again from University of Physics. Let's see this part here. We have a problem, it's a bit of a biological problem, and this talks about the transmission of nerve impulses. So nerve cells transmit electric signals through the long tubular axons. These signals propagate due to a certain rush of sodium ions, each with a charge positive interaction. Measurements have revealed that typically about 5.6 times 10 to 11 sodium ions enter meter of the axon during time of 10 milliseconds. So what is occurring during this inflow charge in the meter of axon? So it's like we're talking about this. Let me just show you a quick picture. Well, just to give you or for you to imagine. Okay, this part. Okay, this part here, we've got here the porters. We call these porters, and if they have opposite direction, we call them antiporters, something like that. And these are sodium ions entering. Imagine from according to our problem, we have 5.6 times 10 11 sodium ions into each meter for like 10 milliseconds, pretty fast. Now, what we need to do is to know the current during this inflow. So we have to know that currents, they have this kind of a unit, and the unit for currents is basically ampere. So whatever we do, our answer should be in amperes. This is my solution. So we have the charge, got the charge there, and we've got here the time. We'd like to say that, yeah, as you can see, it is a difference. Yeah, difference in charge, difference in time, and you divide it, you've got the current. So 5.6 times 11 times 10 to 11 ions. Again, e to 11 just means times 10 to 11. So that is 5.6 times 10 to 11. There's one here. You're talking about ions, but you ain't talking about charge. Remember, we're talking about charge here. The Q is charge, but we only know from our problem 5.6 times 10 to 11. So where did we get 1.6 times 10 negative 19? Basically, each part of a constant that we know. This is the E. Okay, this is a constant. So we know that the Q should have the answer of Coulomb. So if we cancel this part, cancel, ion cancel, we only have the C. So it's perfect because C over S is amperes. And okay, if you calculate, you're gonna have 9.0 microamperes. Okay. So the next question is 25.14. A wire 6.15 meters long with a diameter of 2.05 millimeters has a resistance of 0.0298 ohm. What material is the wire most likely made of? We'd like to know what kind of material we're talking about here, given all of these kind of values. So we're talking about resistivity, right? If we know the resistivity of something, we can likely know the material. So most like that. And can you remember any kind of formula when talking about resistivity? Yeah. So we have this formula. It is with over area. Can you remember that? If not, it's okay actually. Well, I have here a formula. Let me just pull it out real quick. So this one is here. You see this one? This is the formula we're going to use. Okay. The formula that we are going to use, since we'd like to have the resistivity of something. Now, I would like to share with you how I memorize this formula. This is how I memorize it. It's actually Raphael. I don't know if that makes sense, but it's how we memorize it with the letters. It's Ra. It's like Raphael. more or less like that, but with the, well, knowing what the denominator is, what the numerator is, what the flip side is, just to make sure to transpose it real quick and really really correct. So yeah, so just got Raphael. Yeah, so let's see it here. So we have again Raphael and we want P. So transposing, we put it here, it will become AR equals PL, boom boom boom, and then we divide it and we have AR over L. Now what is the A here? Okay, as you can see, when we talk about it, we have the pi, because it has to do with the area. So we have the pi times the D, we know the D, right? The diameter 2.05 millimeters, to make it meters, so we'll have 0.00205 meters, that is diameter, over 2, because we're talking about the, this one, right? So D over 2, so pi times D over 2, this one, okay? Time is not supposed to be equal. I'm sorry, it's supposed to be squared because we're talking about the area and we know the area is squared. So that's the kind of thing. Times R. Get it? Because we're talking about this thing now. Divided by L. So 6.50 meters. Now calculating everything, we're going to have 1.47 times 10 negative 8. And it should be negative 8 ohms meter. So the answer would be 1.47 times 10 negative 8 ohms meter. Okay, that's the answer for our second question. Next one, 25.17. In household wiring, copper wire 2.05 millimeters in diameter is often used. Find the resistance of a 24 meter length of this wire. We're again talking about the resistance basically, so we want to call Raphael again. So Raphael, we want to have the P again. Okay, knowing that no, we don't know anything. Okay, we want to find these kind of things with Raphael. The P equals 1.72 times 10 negative 8 ohms meter. How is that possible? How is that possible? Basically, it's a constant. Okay, that is a P there, and we want to know the resistance or something. So we know that when we are talking about these kind of geometrical shape. Oh, by the way, we're talking about copper wire. If we're talking about this wire with the diameter, length, we know the area is pi r squared. I don't know why I put E again. I'm sorry. Pi r squared. Okay. So that's the area. Now going back here, we want to plug the values in. We have here the constant. Okay, we have a constant. And we have the L, which is the length of that, 24 meters. And then we have the pi constant as well. Just press pi and calculate. And then we have the A, right? So 1.025 times 10 negative 3 squared. Wow, sorry. Okay, squared. So what we can have here is 0.125 ohms. Answer, complete unit is 0.25 ohms. Let me just put it here real quick for your study session and for my grade. 0.25 ohms, that's it. Okay, so the next video we'll be talking about the chapter 26, and I hope you stay tuned. Okay, thank you.